This is 6.3, solving multi-step inequalities. You no longer have the one-step inequalities that we were solving before, but rather now you've got 2, maybe 3 steps you'd need to solve. The steps for solving these are the exact same as when we were solving multi-step equations, but now you've got to remember about solving, graphing, and checking. Every time we're still going to solve these, graph all possible solutions, and check an answer from the shading. Remember, we do not check the dot even if it's a closed one. So looking at this inequality, 4x plus 6 is greater than or equal to 54. I would solve this exactly how I would go about solving the equation. Divide both sides by 4. And since I'm dividing by a positive, I don't have to worry about flipping the inequality. There's my solution. I would graph it on a number line. Look, there's 3 points right there for me. Closed circle, shading greater than, and I would check like number 13 because it is a number bigger than 12. Now, on these, just as before, I plugged in my possible solution. I need to plug it in and solve. You can take as many steps as you want to do this, but you only need 2 steps, a plug in and a solve. So this would be 52 plus 6. 52 plus 6 would be 58, which is greater than or equal to 54. Those are the 2 steps I would be looking for in a check. If you want to do the step in between, you are more than welcome to, but I will not ask you to show it. Again, solving multi-step inequalities is exactly like solving multi-step equations. This was exactly like chapter 3. Looking at this one, I have negative 1/3 times x plus 21 is less than 2. You've got a couple options. You can distribute this negative 1/3 and get rid of that and then solve, or you'd come up with the same answer, or because it's negative 1/3 times this thing, I can get rid of this negative 1/3 by multiplying by its reciprocal, negative 3 over 1, or basically negative 3. That means x plus 21. Now, I've multiplied by a negative, so I flip the sign, greater than negative 6. Subtract 21 from both sides. X is greater than negative 27. You'd get that same answer if you had distributed your fraction. So if you distribute negative 1/3, you'd get negative 1/3 x minus 7. And so I'd add 7 to both sides. Negative 1/3 x is less than 9. I'd still have to multiply by the reciprocal of negative 3. I'd still have to flip the sign, and I would still get x is greater than negative 27. However you want to solve that. Graph it on your number line. Negatives, so 26 would not be it. Negative 28, negative 27. Open circle and shading. I know that I'm going to have to take 1/3 times my number, so let's use like negative 24. So negative 1/3 21, and negative 1/3 times negative 3. And negative 1/3 times negative 3 is 1, which is less than 2. You can always, if you want, 0 would be in the shading. You can plug in 0. It would be perfectly fine. I just like to stay really close because then my solution looks really close. Same thing here. You can distribute or just get rid of it. 2y minus 4.4. Add 4.4. 2y equals, no equals. Greater than, divide by 2. Hey, back to 2.2. You could do that, or right off the bat, divide by 2, and that gets rid of that. I'm dividing by a positive, that's why I didn't flip my sign at all. notice we come up with the exact same answer. It doesn't matter which way you solve this, so long as you show me how you did solve it. Now, you can do this option where you've got the whole numbers 0, 1, 2, 3, 4, or you can make your graph however you want, 2.1, 2.3. So I can do 2 times 2.3, and that's got to be greater than 0. 2 times 0.1, and that's 0.2, which works. Again, I'm only going to look for this first plug-in step and the last check step of your check, but notice each time we're solving, graphing, and checking. You do have to remember back when we were solving equations, there were sometimes lots of steps, where this one I am going to have to distribute because I can't just divide everything by 2. Greater than 8x plus 2. Now, if I've got variables on both sides, I have to subtract my variable term, but notice these completely disappear. And I'm left with the expression 3 is greater than 2. This is a true statement. 3 is greater than 2, so I would say that your solution is all real numbers. Your solution is all real numbers, and that's what you would write for your answer. And we said that because the statement we were left with, 3 is greater than 2, is a true statement. It is correct. But take a look at this next example. When I distribute 24b minus 4 minus 24b on both sides, and you're left with negative 3 is less than or equal to negative 4. Well, negative 3 is not less than or equal to negative 4. So we're actually going to say that this has no solution. If it's not true, then it will never be true. That means there is no solution. And it's all based on that statement. Your answer, though, what you write for your solution is all real numbers. You write your solution as no solution if it's not true. And in both cases, there's no graph, because either there's a graph of all possible solutions, which would be everything, or there's a graph and nothing on it. So you would not graph whatsoever. You might have cases where there are no solutions and all possible solutions, but you don't know that until you start distributing. When I distribute my 1/2, I have 4w plus 16. And when I subtract 4w from both sides, I'm left with 18 is greater than or equal to 16. That is a true statement. So our answer is all real numbers. Here, negative 6z plus 2 is less than 1 minus 6z. Add 6z. Those are gone, and you're left with 2 is less than 1. That is not true. So there is no solution. True is all real numbers. Real numbers is basically anything that's not imaginary. And no solution means it was false. You will also have to write inequalities multi-step. So your cell phone plan is $35 a month. $35 a month, that means $35 times each month for the 1,000 minutes. Now you are charged 25 cents per minute, means 25 cents times each minute for any additional minutes. So what is the possible number of additional minutes you can use if you want to spend no more than $50 on your monthly cell phone? So they're only talking about 1 month at a time. So my $35 is what I'm paying for the month for the 1,000 minutes. It's the 25 cents for each minute after that that I have to worry about. Now, I don't want to go over 50. So I've got 25 cents per minute, M, and my monthly fee of $35 for the month. Now, I don't want to go over $50. That means I need to be less than or equal to $50. And then you would go about solving this multi-step. Remember, solve it, graph it, and then check it with a number from the shading. So subtract 35. 25 cents per minute has to be less than or equal to 15. And divide that by 25 cents. And your number of minutes is 60. So you can go over 60 minutes. I would graph it. 50, 60, less than. And I'm going to have to multiply this by something. So let's go something I can do in my head, like 40. Because 40 times 25 cents, it takes 4 quarters. So times 10, that'd be $10 extra. 35, that would be $45, which is less than 50. So you can talk for 45 minutes. All right, you will have a problem like this on your homework. You're training for an Oreo eating contest. Sounds like fun. You're building up your stomach capacity by eating Oreos for 5 minutes straight every night. The following data tells how many Oreos you've been eating for the last week. You ate 57 on Monday, 42 on Tuesday, 39 on Wednesday, and 48 on Thursday. You want to average at least 50 Oreos in 5 minutes. How many would you have to eat on Friday to reach your goal average? We would set this up. So Friday, how many we'd have to eat on Friday is our X. If you had all this information, you would take the 57 plus the 42 plus the 39 plus the 48 plus the Friday, divide that by 5, and you'd want that to be at least 50, so greater than or equal to 50. And we'd go about solving this like we do. Combine all of those, add those all up. Let me grab my calculator. So 57, 42, 39, and 48. That's 186 plus x divided by the 5. Undo the divided by 5. And that has to be at least 250. And you've got to eat at least 64 on Friday. Ugh. 64 Oreos on Friday. Is it reasonable to think that you will meet your goal? Yes, with an icky stomach. But if you look at our data, 64 is really high compared to everything we've done. No, because it is so much higher. Or you can say yes, because it is, you have been taking it easier than you were on Monday. Whatever your answer, make sure you can justify it. And here's your homework for 6.3.